Okay, so I want to go back through the reading real quick, just so I can get it on the recording. So today, polynomials, that's what we're talking about, okay? Polynomials. And what we know about polynomials is the thing, poly means many, so it's many terms. If I look at my example, it's got lots of different terms, and terms are separated by plus or minuses. We know if in a polynomial we have to have whole number exponents. That means that the exponents must be whole numbers. And this has an exponent of 0, okay? Can't be negative exponents, can't be fractional exponents, it has to be just regular whole numbers. The thing about polynomials is they are wavy things, and the higher the degree, the more curves you get in the polynomial. We'll learn that as we go, okay? Now, a monomial is one term, a binomial is two terms, a trinomial has three terms, and I have examples for each. Monomial, binomial, trinomial. The degree of the polynomial is probably the most important thing we're going to learn in this chapter. It's very important because it tells us a lot of things, and it's just the biggest exponent, okay? So in this example, you've got a degree of 4, degree of 2, degree of 3, and degree of 2, okay? And the leading coefficient is simply the number in front of the biggest term, okay? Which in this case would be the 5, the 3, the 4, and the 1. And there's also a thing called the constant. The constant are the numbers that do not have a variable with 5, 0, 0, and 12. Okay, so now let's look at the actual notes, right? So the actual notes start off with just some easy stuff. And we're going to name them. We're going to find their degree. We're going to find the leading coefficient. We're going to figure out what the constant is, okay? So the first one, the name, well, there's 1, 2, 3, 4 terms. We don't call it a quadnomial. We just call it a polynomial, that's all. Polynomial. So, anything bigger than 3 is going to be called a polynomial. Degree is the largest exponent, which is 4. Leading coefficient is the number in front of the biggest degree, which is the number 3. And the constant is any number by itself without a variable. That's just the 1.
Sweet.
It's pretty easy, isn't it?
Yeah.
H of x, it's out of order. It's out of order. So the name, there's 1, 2, 3 terms. It's a trinomial. It has a degree of 3, and we should rewrite this in standard form or in what we call descending order. I should write it as an h of x equals. I should rewrite it so the 5x cubed goes first because the biggest one goes, then minus 3x, then plus 10. And once we rewrite it in order, then our degree is 3. Our leading coefficient is the 5 because it's the number in front of the biggest exponent. And our constant's the 10. It's that easy. This one's got 1, 2, 3 terms, so it's also a trinomial. Has a degree of 2, and the leading coefficient is 1. It has a constant term of 3. Pretty easy. K of x, it's a binomial. Its degree is 1. Its coefficient, leading coefficient is 4. And its constant term is 1. It's easy. Last one, f of x, don't get too confused because it's really, in a sense, 5 times x to the 0 power. You'd never write x to the 0 power, but you could. It is a monomial. Its degree is 0. Its degree is 0. Its coefficient would be 5, which is also its constant, isn't it? That's the only tricky one. Okay, number 2. All we're going to do is add. Now when I add, we've got to make sure that we keep things in order. So when I look at number 2, I'm going to start with the biggest term. So the biggest term is the 14x cubed. And I'm looking at it, okay, well, there's no other x cubes, right? So I'm just going to write it down, okay? 14x cubed, right? And then the next would be the x squared. So I got a 3x squared. And I have a 1x squared. 3x squared plus a 1x squared is going to have to make a 4x squared. I've got an x plus a minus x. Those just kind of cancel each other out. I can't zoom, but once it starts recording, I can. You can come sit up closer though, Grace. You're always welcome to. And then 7 plus 2 is 9. That's all I do. Okay? Grace, you're welcome to sit right up there. Okay. Now, example 3. There's 2 ways to do example 3, and you do not have to do my trick. If you're good at this, if you're good at seeing that we're going to subtract negatives, and don't worry about it. Me, I make mistakes all the time. So what I do whenever I see a subtract is I'm going to bring that negative through and change all the signs and add. I'll say that again. For me, because I make mistakes, I'm going to bring the negative through, change all the signs, and then add. So I'm going to rewrite as a 2x cubed plus a 4x minus 2x squared plus 3. But then I'm going to have a minus 3x. I'm going to have a positive x squared. It just helps me because I would make a mistake. I'm going to have a minus 2x cubed, and I'll have a positive 10. Okay, so what I did is I just brought the negative through and made it an addition problem. Okay, now I'm going to add. So here's a 2x cubed. Here's another cube. This 2x cubed minus 2x cubed just cancels those, right? Squareds. Okay, I've got a negative 2x squared and a positive 1x squared. Makes a negative 1x squared. 4x and a minus 3x makes a positive 1x. And finally, a 3 plus 10 makes a 13. Okay, and all of those can again be made by just being careful and going, well, I'm subtracting a negative, which means plus. I'm subtracting a negative, which means plus. So you don't have to do it the way I do it. Just for me, it makes it easier if I just push the negative through, change all of these signs, and then add them, okay? All right, example 4. Example 4 is a big FOIL problem. But I don't like the word FOIL. In fact, I never have. What I like to use instead is distribute. So the 3x is going to be multiplied here, here, and here. So I'm going to distribute the 3x all the way through. And then the negative 2 will be distributed here, here, and here. So really, just think about 3x times all of these 3 terms, and the negative 2 times all 3 of these terms. So that's not so bad. So let's do it. 3x times 2x squared is a 6x cubed. Then 3x times 3x is a positive 9x squared. And then a 3x times a negative 1 is a negative 3x. Okay, so I took 3x times all 3 of these terms. Now I'm going to go the negative 2 times all 3 of these terms. So negative 2 times 2x is a negative 4x squared, but I'm going to put it right here, negative 4x squared, because I want to line things up. Eventually I'm going to have to add them, so I like to add up the things that are the same, because then it makes it easy to add, right? The same thing here, I'll get a negative 6x, I'll put that right there. I'll line them up, right? Then I get positive 2. Because now when I add them, it's just really easy. Just add straight down. I got the things that go together lined up, so I'll get a 6x cubed plus a 5x squared minus a 9x plus a 2. These are easy, just don't make mistakes, okay? Just don't make mistakes. Okay, return the page. All right. Now, if you don't have a calculator, please go grab a calculator. Grab a calculator, grab a good one, because we're going to graph these, all right?
Taylor, you got one, please?
Okay, grab a calculator. Let's make sure our window is negative 10 to 10. Negative 10 to 10, okay? Standard window, okay? Oh, there, you just being a good friend, huh? Okay? Now, first of all, make your window a standard window. Okay, negative 10 to 10. Okay, so give me 5. So here we go. Go to y equals. Go to y equals. And let's put in a 2x to the third power, subtract 3x, okay? So you ready? A couple of buttons to push to the power. So with 2, this is the power of 2x variable to the power of 3 minus 3x, okay? Okay. So this is to the power of button right here, this little, they call it a caret. Negative 10 to 10. Negative 10 to 10. Here, I'll go back to window. Right? Okay, you see that? Okay. So I got negative 10 to 10. Standard window, negative 10 to 10, negative 10 to 10, right? Y equals, right? Let's graph it. Let's see what it looks like. Okay, everybody get this picture. If you didn't, let me know. Are we all out?
How do you use
That one's low battery.
That's okay, it'll work for a
It
while.
still works.
It still works. Here,
Mr. Davis, how do you type cubed?
here, I'll give you batteries.
It's just to the power of.
Here, I'll give you batteries. Okay?
Oh no, I don't got that.
Arthur, excuse me. Good. So if anybody watches this film, be prepared for lots of pauses. Okay, so let's put that on my graph. Looks like this. Okay, did you get that? All right.
Do you press enter to make it do the graph?
Just push graph. Just push the graph button. Okay. So, yes. If you guys are having trouble with your calculator, I'll look later, okay? Just follow along. So first of all, you guys get this answer?
Yes.
So, how many places does it cross the x-axis? 3 times, right? So it has 3 real roots, or 3 real zeros. Has 3 real zeros. 1, 2, 3. So at this point right here, the height, or the y value, is 0. This spot, the height, or the y value, is 0. This spot right here, the height, is 0, so the y value is 0. So it has 3 real zeros.
This looks like
Real. Yeah, real. How's that? Okay, let's graph B. Let's see what B looks like. Go to y equals. Clear. X to the 4th, subtract 8x squared plus 1. Okay? Alright. Okay, x to the 4th power minus 8x squared plus 1. Okay? Graph. It is. It's a big W. Now, I don't see all of it, but I can change my window to see more of it. If I want to go further down, I go to my window. No, you don't. Great question. Who said that? Totally right. I might just look at it anyway, but here it is. Totally right. So, it looks something like this.
Like a W?
Yeah, like a W.
W.
So what we're going to find out is the bigger the degree, the more curves it's going to have. The bigger the degree, the more curves it's going to have. How many zeros? How many real zeros? 3. And what we're going to find later, not today, we're going to find that technically this one has 4. Listen carefully. It technically has 4 because this one here is counted twice. Think about this. I want you to watch. Don't talk. Just it's going to go through once. It's going to come right here. It's going to go through here and then back through it again. So technically, right here it's counted as twice. It's called a double root. We'll talk about that another day. Okay? So it really does have 4, but we'll only count 3, okay?
So it all just depends.
Yep. Okay. I can do C without a calculator. 1, 2, 3, 4. If you want to put it in the calculator, go ahead. I know it looks like this. I do. Okay.
That your life on it?
Yep.
Now I'm checking.
So I know how many real zeros? 2 real zeros. 1. They're right here. 1. Okay, now, how do you test the zeros? It's even though. So how do you test them? Shh. This has x equals 2 and x equals negative 2 are the zeros. The way you test them is this. You gotta listen. It's a 0 because when you plug it in, you get an answer of 0. I'll say it again. It's called a 0 because when you plug it in, you get an answer of 0. So let me plug 2 into the original equation. I'd have y equals x squared minus 4, or y equals a 2 squared minus 4, which is 0. So if you can plug a number in, any number plugged in that makes it equal to 0 is a 0. I'll say it again. Any number plugged in that makes it equal to 0 is a 0. They also happen to be the x-intercepts until we get to I, which we won't talk about I today. Okay? All right, last example. Example 5. We're almost finished. All right, a cardiac outpatient of a particular patient can be approximated by the function 0.0056t cubed minus 22.22t squared plus 2.33t. Okay, now, f of 0. How do you find f of 0? Plug it in. So we're going to go f of 0 equals 0.0056 times 0 cubed minus 0.22 times 0 squared plus 2.33 times 0. And I don't need a calculator to do that at all. It's just 0. Because it's 0, 0, 0 makes 0, right? F of 3, how do I find f of 3? Plug it in. F of 3, 0.0056 times 3 cubed minus 0.22 times 3 squared plus 2.33 times 3. I will definitely use my calculator because I don't want to have to do that without a calculator. So, yeah. So I'm just going to go 0.0056 3 cubed minus 0.22 times 3 squared plus 2.33 times 3. I give it a 5.16, okay?
That's all you have to do?
That's it. Wasn't that easy? All right.
What does it mean?